Okay, this is solution for hypothesis testing for one population mean. Okay, look at example 3. The management of Trust Health Community claims that its member lose an average of 10 kg or more within the first month after joining the community. The consumer agency who wanted to check this claim took a random sample of 36 members and found that they lost an average of 9.1 kg within the first month. The population standard deviation is known to be 2.4 kg. Find the p-value of this test. What will be your decision if alpha equals to 0.01? Okay, look at the information given to us. Okay, kita ada random sample of 36. Okay, we have n equals to 36. Okay, and then we have x bar equals to 9.1. And the population standard deviation. Okay, so kita tahulah value of population standard deviation equals to 2.4 kg. Okay, so this one is case for known population mean. And we have alpha equals to 0.01. So our first step is constructing the H naught and H1. So we want to test on mean. So for H naught, kita nak test mu greater or equals 10 versus mu less than 10. Okay, so this one is right tail. Left tail. This one is left tail sebab kita punya sign less kan. Okay, step yang kedua, we want to calculate the test statistic. So since population standard deviation are known, we're gonna use Z. So Z will be equals to x bar minus mu naught. So our x bar is 9.1 minus mu naught kita adalah 10 bahagi dengan 2.4 over square root 36. So we get Z equals to negative 2.25. Okay, since this question want us to use p-value approach, so you have to find what is the p-value for negative 2.25. So based on table Z, probability of Z less than negative 2.25 is equivalent to 0.01222. Okay, so critical value here is alpha lah sebab kita guna p-value approach. So our alpha is equivalent to 0.01. Our decision rule, we're gonna reject H naught if p-value less than or equal alpha. Okay, so since 0.01222 is greater than 0.01, so we fail to reject H naught. So means that the mu is more than or equals to 10. Okay, now look at example 4. A report released some years ago state that a typical family spend an average 20 per day on food. Suppose a recent study on a sample of 50 family. So we have n equals to 50. Found that they spend a mean of Rm22 per day. X bar equals to 22. We are interested to know whether the true population mean is now greater than 20. The population standard deviation is known to be RM5. Okay, so yang ni pun sama. Population standard deviation are known, which is equivalent to 5. Okay, find the p-value to test that the current mean amount spent on food exceed 20. Will you reject the null hypothesis at alpha equals to 0.02? Okay, so proceed to our first step, H naught and H1. So we want to test exceed 20. So mu naught mu naught equals to 20 versus mu naught greater than 20. So this one is right tail. Step yang kedua, calculate the test statistic. So we're going to use Z because we know the population standard deviation. So Z equals to X bar 22 minus 20 over 5 over square root 50. So we get value of Z equivalent to 2.828. 2.828. And then proceed to find the probability value. Probability value of Z greater than 2.828 is equivalent to 0.00233. Okay, now kita dah ada p-value. Step yang ketiga, decide on the critical value since we use the p-value approach. So, critical value is alpha equals to 0.02. Okay, step number 4, write the decision rule. Reject hash naught if p-value less than or equal alpha. Less than or equals to alpha. Okay, number 5, okay, look at our p-value 0.00233, which is greater than 0.02. So since 0.00233 is greater than 0.02, we fail to reject hash naught. Fail to reject hash naught. Okay, means that mu is equivalent to 20. Okay, we proceed to example 6. An inventor has developed a new energy efficient lone mover engine. He claims that the engine will run continuously for 5 hours. A random sample of 50. So we have n equals to 50. N equals to 50. An average of 295. So x bar equals to 295. Standard deviation, sini S lah. Standard deviation equals to 20. Sebab apa S? Sebab apa kita kata dia sample? Sebab maklumat tu datang selepas dia ceritakan tentang sample. Okay, so this value of standard deviation is referring to the sample. So this one is the population standard deviation are unknown. Okay, but if you look at the sample size, which is greater than 30, we still use Z. Okay, so this one is case number 2 lah. Okay, test the null hypothesis that the mean runtime is 300 minutes. Again, not 300 minutes. Okay, so dia dah beritahu kat situ hash naught h1 dia lah. So our hash naught and h1 is mu equals to 300, mu not equal to 300. Okay, so this one is two-tailed test. Okay, now the second step is we want to calculate the test statistic. So the test statistic is Z equals to x bar minus mu naught 295 minus 300 over S over square root n, 20 over square root 50. So we get Z equals to negative 1.7678. Okay, critical value. So since this one is two-tailed, so it's going to be plus minus Z alpha over 2. Alpha is 0.05 divided by 2, 0.025. So it will be plus minus 1.96. Okay. Negative 1.96 at the left tail and 1.96 at the right tail. Okay, now write the decision rule first. So reject hash naught if test statistic less than negative 1.96 or test statistic greater than 1.96. Okay, now look at our test statistic value. We get negative 1.7678, which is does not falls in the rejection region. So what can we say? Since the test statistic is greater than negative 1.96 and test statistic less than 1.96, ataupun actually awak boleh tulis macam ni, since negative 1.96, test statistik tu berada di antara 1.96. Okay, boleh buat cara macam ni juga ataupun buat ayat macam ni pun boleh. Okay, since dia berada in between dia punya critical value, so we fail to reject. So fail to reject hash not. Fail to reject hash not. So when we fail to reject hash not, mean that the mean equivalent to 300. Okay, now look at example 8 pula. A gas company claimed that the length of time between a gas leak being reported and engineer arriving to investigate has a mean of 113 minutes. A random sample of this time in minute was, okay, you are given the raw data. Using the 5% significant level, test whether there is evidence that the mean time exceed 113 minutes. Assume that the distribution of time is normally distributed. Okay, so for this case, first awak kena calculate dulu what is the x bar value for the random sample. So based on the calculator, I get x bar equals to 130.25 and the sample standard deviation equivalent to 50.2302. So n kita ada 8. Okay, now construct the hash not and h1. So we want to test on mean. Okay, whether it was exceeded 113. So hash not kita mu equals to 113 versus mu greater than 113. So this one is right there. Okay, second step, calculate the test statistic. So we're gonna use, okay, this one, since we does not know the population standard deviation and the sample size is small, which is less than 30, we're gonna use T. So T equals to x bar 130.25 minus 113 over 50.2302 over square root 8. So we get the T equivalent to 0.971. Okay, the third step, find the critical value. Okay, so our critical value is based on T distribution lah. So T alpha is 0.05 and minus 1. 8 minus 1 is equivalent to 7. Okay, so based on the table, the value is 1.895. So kalau kita lukis, dia di sebelah kanan, 1.895. So baru kita buat dia punya decision rule. So the decision rule is reject hash not if test statistic greater than 1.895. Okay, now look at our test statistic value. It was equal to 0.971, which is does not falls in the rejection region. So we can conclude that since test statistic is less than 1.895, we fail to reject hash not. And then we can see that mu is equivalent to 113. Okay, for example 9, a calculator battery has a population mean life of approximately 330 hours. A random sample of 20 calculator was tested. So n we have 20. And it was found that the mean and standard deviation of this sample is x bar equals to 332 and standard deviation of the sample equals to 12.5. Okay, assuming the battery life is normally distributed, test the hypothesis that the population mean is less than 330. Okay, so our hash naught and h1 is mu equals to 330 versus mu less than 330. So this one is left tail. Okay, our test statistic, we're gonna use T also here because we does not know population standard deviation and our sample size is small, which is less than 30. So T equals to x bar 332 minus mu naught 330 over 12.5 over square root 20. So we get our T were equivalent to 0.7155. Okay, number 3, find the critical value. So since this one is left tail, so don't forget to put negative T alpha 0.05 and minus 119. So based on the table, we get the value is negative 1.729. Okay, so look at the left tail, our critical value negative 1.729. So we can write the decision rule. Reject hash naught if test statistic less than negative 1.729. Okay, so what is the conclusion? Look at our test statistic is equivalent to 0.7155. Okay, which is does not falls in the rejection region. So we can say that since test statistic is greater than negative 1.729, fail to reject hash naught. So when we fail to reject hash naughts, mean that the means are equivalent to 330.